This video is continuing triangle theorems. In triangles, so we ask ourselves, what do the angles add up to in all triangles? So in all triangles, the three angles will actually add up to, every single time, 180 degrees. All triangles, all the angles, the three angles in a triangle add up to 180 degrees. What is special about exterior angles? So we have a theorem, it's called the triangle exterior angle theorem. It states that the measure of each exterior angle of a triangle equals the sum of its two remote interior angles. So let's define what exterior angles are. An exterior angle is an angle formed by a continuing side of a triangle. And since it's called exterior, it's obviously going to be on the outside. So if we look back at this triangle up here, of the three sides of the triangle, we want to figure out are any of them continuing. This side is not continuing. This side is not continuing. This side, as I keep going, it does continue. The angle that's on the outside is angle 1. So if I outline this angle 1, this is considered your exterior angle. Now let's define what remote interior angles are. Remote interior angles are the two angles that are not touching the exterior angle. Which, if it's not touching, it's called the non-adjacent. So if angle 1 is our exterior angle, angle 2 is not touching this blue highlight, and angle 3 is not touching the blue highlight. So these two angles, if I were to outline them, would be our remote interior angles. What this states is that if I know these two measurements, I can add them, and that's automatically what this angle is on the outside. That's what this theorem states. However, you can still do this. You can still figure out this angle without doing this theorem, especially if you only have numbers. However, if you have variables, it would be greatly beneficial if you knew this theorem. But if these are just numbers, if you add these two up, we know that all three of the angles have to add up to 180. So if we know these two, we can subtract those two from 180, and we'll have the third interior angle. Well, this interior angle and angle 1 form a line, so they are a linear pair, which means these two are supplementary to each other. So if I know this angle, I can subtract this angle from 180 to get to the outside. It's just a little bit easier just to add these two and be like, that's our answer. That's what is special about exterior angles. It does continue from a side. If I had made this go up like that, it would not be an exterior angle, a triangle exterior angle, because it wouldn't continue from a side if it went like that. We're also going to talk about isosceles triangles. So what is an isosceles triangle? Well, if we remember, the definition of an isosceles triangle is that if you have to have at least two congruent sides of a triangle to be considered an isosceles triangle. So to form an isosceles triangle, we have to have two congruent sides. And if we show congruency on the sides, those are the tick marks, we can say that two of the sides have the same amount of tick marks, meaning these are congruent. This is an isosceles triangle now because I have the two congruent tick marks. Now, these are considered, on an isosceles triangle, the two congruent parts are considered the legs. These are both considered a leg. The third side, which is not congruent, is considered your base. So these are the sides of an isosceles triangle. We have the two legs and the base. Now the isosceles triangle theorem states, again, this is about theorems, triangle theorems. So it says if two sides are congruent in an isosceles triangle, then the angles opposite those sides are congruent. And I've talked about this in a previous video. The angles opposite of these congruent legs must be congruent as well. So I have one arc on this angle, and if I have this side is congruent, go across this triangle to go over to here, gives us our other congruent angle, and we have one arc on both of those. So we have two congruent angles. Now, it states if two sides are congruent, then the angles opposite those sides are congruent. There's actually called a converse. The converse of the isosceles triangle theorem states that if two angles in a triangle are congruent, then the two opposite sides are congruent. So it says if two angles in a triangle, a single triangle, are congruent, then two opposite sides are congruent. So if we had these marked congruent, then we could say the sides across from them are also congruent, since it's in a single triangle. There's also called a corollary of this. A corollary is kind of like, it's an extension off of this. This information holds true for equilateral triangles as well. So the corollary states if a triangle is equilateral, so all sides are congruent, then the triangle is equiangular, meaning that all the angles are congruent. And you have the corollary of the converse, which states that if all three angles in a triangle are congruent, then all three sides are also congruent. So if it's equiangular, it's equilateral. That is the corollary of isosceles triangles. Now going back with the angles, these two angles, since they are congruent, these are actually called your base angles because they are attached to your base. These are the base angles. Your base angles in an isosceles triangle are congruent. This angle up here, since it's across from your base, would not be called your base angle because obviously your bases are down here. This angle up here where the two congruent sides meet is actually called your vertex angle. This is called your vertex angle up here because it's where these two meet.